Hi, my name's Elliot, and today we'll be looking at using Chalk to stop fraud at a bank. In particular, we have some really clever users who figured out how to withdraw their money at the same time as they issue a return and get their funds back twice. We want to stop them before they make that withdrawal so we can stop this fraud problem. To do that, we're going to pull in a lot of data from some really real-time sources. We'll look at integrating with production Postgres databases, at integrating with APIs and data vendors, and finally at using cached values in the way that more traditional kind of reverse ETL systems work. So we'll start by laying out some features. We apply this little @features decorator to a class, and then all of the annotations on that class become our features. So for example, the normalized value of the email is our primary key. We have a feature called deny listed that determines whether or not the email appears in a deny list backed by an S3 list. And some window functions, for example, the number of unique IPs that have been associated with a given email. And finally, we have links to other bags of features. So an email, for example, has been observed many times via login events. And that email observation then also links back to the email. So now that we've laid out some of our features, we can go set some resolvers to define how we actually go compute these values. The first way we'll look at doing that is via a SQL file resolver. So this is just going to connect data from our transactional Postgres database into Chalk. So first we say that we have a source, which is our Postgres demo database, and it's going to map into the email observation feature class. Now, the way that we grab that data is via the select statement. So we're selecting the ID, the normalized, the user ID, and the aliased as the observation date from the email observations table. All of these line up with features in our email observation. And so we'll be able to kind of map that data in. What's really nice about this is you can just run these files to see what data you have. And we'll also be able to reuse this same SQL file resolver for many different ways of slicing your data. So for example, if you needed all of the email observations for a given user, Chalk would push down a filter that only considered email observations for that user. So that's how we'd write a SQL file resolver. But if we want to express things like more complicated data dependencies, or if we wanted to grab data from an API vendor, we could fall back to writing a Python function. So here we're going to look at integrating with a vendor called EmailAge that's going to provide us things like how old an email is. So we'll put this decorator @online on top of a normal Python function, and then express our data dependencies in the type signature of the arguments. So here we're saying we need a normalized value of an email. Not that we know how to get it or where it's coming from, but just that we have one. And if we've got one, then we can compute the EmailAge raw score by calling out to the EmailAge client and passing it our email. So that'd be how we'd integrate with this EmailAge client. But we can also express much more complicated dependencies and even encode things like temporal consistency inside of these resolvers. So to look at an example of that, we'll compute a histogram for the number of times an email has been seen in the last 2 years. What we'd like to do is create some buckets, 8 of them, that represent how many times an email has been seen in each quarter. Here I'm taking in the observations for a given email. And if I jump to the definition of this, that's just our data frame of email observations on the email feature class. And I just want the date property from features in the last 2 years. We'll bucket these on the data frame method histogram list inside of the body of the function. Now, one of the things that's really interesting about this is we're actually expressing now, or the time, in terms of this abstract variable. And when we're doing inference, this is just going to be datetime.now. But because this is abstract, we can backfill this function using all kinds of different values of now. So if you wanted to know what did the email histogram look like a year ago, we could then sub in a year ago for now here to compute that value. So now that we've written a few resolvers and defined a lot of features, we can go query for some of these values. We'll hop over to the command line, and we can use Chalk's CLI tool to get all of the features back for an email. So here I'll pass in just the email that I know. I could also pass in other things from, say, a checkout form, and we'll get back all of those features here. Now, we can also get back other feature sets which are linked to this email. So for example, if I wanted to know about the observations of a given email, I could pull back the email observations, or I could ask for both the properties of the email and the email observations. What's really nice about this is that this means you get feature reuse across all of your different models and applications. So if you have a data scientist who's working on email features for, say, account takeover, those same features can be leveraged by another team which is maybe entering through a different point, like a transaction. So that's how we go query for some of these values. In practice, you'd probably run something like CodeGen to go create like a Go or TypeScript or Node client so that you can go query some of these feature values. And we give you nice, strongly typed definitions for all of these things. So what's happening behind the scenes, right? We like asked for some real-time data back, but like, how did it know what to stitch together? And for that, we can go jump into the web. So I'll open up the Chalk dashboard, and we can head over to the queries page where we can see all of the queries that we've run recently. So here's some of them. I'll grab this one here. And we can see this was for, we passed in an email. We wanted to know many of the properties of the email. And to do that, Chalk computed a query plan. So if you've ever run like Postgres explain analyze, or you've looked at the Snowflake query plan viewer, you might be familiar with something like this. We've got things like joins and projections, but let's just collapse this down to the functions that we ran. So we can see here, for example, we have the get email age feature. We have parsing out some features from that email age. We have our observation histogram here. So all of these are being run in reaction to your query, like right when they're needed. Now, we can also introduce some caching here if, for example, some of these are slow or expensive to run. So if we jump back into the code, we can go over to, say, the email age raw feature and say, well, this one, we pay email age a few cents or $1 to get back this feature value. So I'll take any one of them that's been computed in the last day. I don't need these to be like computed on the fly every time. And if I want to pre-fill that cache, I can also run this function on a schedule. So to do that, I would just add a cron argument to this online resolver here and express that, say every day I wanted to go recompute this feature value. So that's querying some of these values and what Chalk's doing under the hood to do it. But now let's go look at what it looks like to add a new feature to our existing set. So we'll do a really simple one. We're just going to compute whether or not an email is Hotmail. And I'll say that's a Boolean feature. That we want to know, like, hey, is the domain Hotmail or not? Maybe that's a useful feature for our model. So we'll write a new resolver, write at online, and say get is Hotmail. Now to determine this value, I just need to take in the domain name for the email. So I'll take in the domain name, and then I'll output user.isHotmail. And to do that, all I need to say is like, well, is this domain Hotmail or not? So now that we've written this, we want to go test our change. We're not yet ready to deploy it to production, but we want to see what this would look like were we to deploy it to production. So to do that, we can deploy our change to what's called a branch. So if we jump over to the terminal here, we can run chalk apply, which is the normal way to deploy, but add this extra flag branch. By default, this will just pick up our Git branch and deploy all of our software there. Now, these scale down to 0 and up to thousands of CPUs, so you can really experiment here at very low cost. Or you can build it up to really run a big backfill. So we've deployed our change, and now we can go query that same email again. So I'll run chalk query for that given email, but this time I'll supply this flag branch, which means I'm going to look at that branch that we just deployed. Now, when this data comes back, I can see this is Hotmail is true coming back. We can test this same code in a notebook too. So this is testing like one key at a time. But if you'd like to run a backfill, you can do that from your Jupyter notebook by just setting up a chalk client via the Python API client and running what we call an offline query to recompute a bunch of our features. So that's how we use chalk to do data science. It's really, really helpful in environments when you need real-time data or just want to be able to iterate really quickly and have a lot of folks experimenting at a time. If you have any questions, please check out our docs or reach out to us. Thanks so much.